Steps in logarithmic differentiation. Number 1, you take natural logarithms of both sides of an equation y is equal to f of x and then use the laws of logarithms to simplify. 2, differentiate implicitly with respect to x. And number 3, solve the resulting equation for y prime. Now, if f of x is less than 0 for some values of x, then the natural log of f of x is not defined. But we can write the absolute value of y, which is equal to the absolute value of f of x, and then use equation 4. We illustrate this procedure by proving the general version of the power rule as promised in section 3.1. So the power rule, let's talk about the power rule. That means that we're going to let f of x equal to x to the n, which is the same thing as y, which is equal to x to the n. Now, if we want to write this in logarithmic form, by taking the natural log of both sides, then that means that we have the natural log of the absolute value of y, which is equal to the natural log of the absolute value of x to the power of n, provided that x does not equal 0. Okay, so now we're going to take the derivative here. So if we take the derivative and differentiate implicitly, we're going to have 1 over y times y prime, which is the same thing as y prime over y. And that's equal to, we're going to have n over x. Now, let's solve for y prime. If we solve for y prime, that means we need to multiply both sides by y. So if we multiply both sides by y, that means we're left with y prime, which is equal to ny over x. So let's go back to what y was equal to. Well, we know that y is equal to x to the n. So what are we going to replace this y to be? Well, we're going to replace it with x to the n. So we have y prime, which is equal to n times x to the n over x. Okay, and then the next step is to then simplify the x's. So it's going to be n times x. Well, if this is 1, when you divide the same base, you subtract your exponent. So this is n times x to the n minus 1. And therefore, there is our definition. So the power rule states that if n is any real number and f of x is equal to x to the n, then f prime of x is equal to n times x to the n minus 1. Now, you should distinguish carefully between the power rule, where the base is variable and the exponent is constant, and the rule for differentiating exponential functions, a to the x prime is equal to a to the x times the natural log of a, where the base is constant and the exponent is variable. So make sure you're careful of those two rules. In general, there are 4 cases for exponents and bases. Number 1, derivative with respect to x of a to the b is equal to 0, where a and b are constants. Number 2, the derivative with respect to x of f of x to the power of b is equal to b times f of x to the b minus 1 times f prime of x. Number 3, the derivative with respect to x of a to the power of g of x, which is equal to a to the g of x times the natural log of a times g prime of x. And number 4, To find the derivative with respect to x of f of x to the g of x, logarithmic differentiation can be used, as we will see in the next example.